students, welcome to Sunil's tutorial. I'm Sunil Midwani and today we'll be doing this chapter called as random variable. Let's see this. Can the following distribution be be a random variable of x? They bring you the data 0, 1, 2, 3, 4. Probability of x is given to you as 0.1, 0.2, 0.4, 0.2 and 0.1. Fine. Now you have to find out whether it is random variable of x or no. First thing that you need to do is you need to find out sigma px. Find out sigma px. Sigma px will be addition of all the probabilities if I add all of them 3, 7, 9, 1. Right? Now since sigma px is equal to 1, therefore the given distribution is a random variable. For it to be random variable, sigma px should be 1. Next, let's see the next sum. Similar type, x 0, 0, 1, 2, 3 and probability of x is 0.2, 0.4, 0.4 and 0.2. Right? How do I solve this? Find out sigma px. Sigma px will be 0.2 plus 0.4 plus 0.4 plus 0.2. 8, 1.1, which is not equal to 1. Since sigma px is not equal to 1, therefore the given distribution is not a random variable. Next, let's see another sum. A random variable of x has the following probability distribution. Random variable has the following distribution. Then when you x, the values of x are 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. Probability of x 0, k, 2k, 2k, 3k, k square, 2k square and 7k square plus k. Right? Now, since the given distribution is a random variable, since the given distribution is random variable, therefore sigma px should be equal to 0. That means 0 plus k plus 2k plus 3k plus k square plus 2k square plus 7k square plus k should be equal to 0. No, sorry, 1. Should be equal to 1. Now, in which case I can say that, let's solve this. This will be 7, 9, 10k square plus 3, 5, 6, 7 plus this is going to be Mr. 2k. So this is 3, 5, 8 and 1, 9. 9k plus minus 1 should be equal to 0. 10k square plus 9k minus 1 should be equal to 0. Let's solve this. This can be written as 10k square plus 10k minus k minus 1 is 0. 10k k plus 1 minus 1 k plus 1 is 0. So I can say 10k minus 1 k plus 1 is equal to 0. 10k minus 1 is 0, therefore k is equal to 1 upon 10, or k plus 1 is 0, therefore I can say that k is equal to minus 1. But we know that probability can never be negative, but k cannot be negative. Therefore I can say that k is equal to 1 upon 10, right? Now in this sum, let's put in an extra question and see, because this will make things very simple. We found out the value of k. Let's see, you have to find out probability of x is greater than equal to 5. If they ask you to find out probability of x is greater than equal to 5. Now probability of x is greater than equal to 5 will be nothing but probability of 5 plus probability of 6 plus probability of 7. Probability of x greater than equal to 5 will be nothing but 5, 6 and 7. All the numbers which are greater than 5. From 5 to the numbers which are greater than 5. So probability of 5 we have is k square plus probability of 6 is 2k square plus probability of 7 is 7k square plus k, right? So in which case you will get this as 7, 9, 10k square plus k, right? But we know the value of k, 1 upon 10. So 10 into 1 upon 100 plus 1 upon 10. 1 upon 10 plus 1 upon 10, 2 upon 10, which is nothing but 1 upon 5. So probability of x is greater than equal to 5 will be 1 upon 5. Next, if they ask you probability of x is greater than 3 and less than 6, you have to find out probability of x greater than 3 and less than 6. Probability of x greater than 3, that will be probability of 3 plus probability of 4 plus probability of 5 plus probability of 6. I want numbers greater than 3 and less than 6, right? Now probability of x is equal to 3 is going to be 2k, 4 is 3k, 5 is k square and 6 is 2k square, right? So in which case I'll get this as 5k plus 3k square, but we know the value of k, so 5 into 1 upon 10 plus 3 into 1 upon 100. When we simplify this, you will get this answer as 53 upon 100. Fine, we get this in here. Next, let's move on to the next one, guys. Two marbles are drawn at random. Two marbles are drawn at random. Two marbles are drawn at random from a bag containing 3 white. Two marbles are drawn at random from a bag containing 3 white and 2 yellow marbles. Containing 3 white and 2 yellow marbles. If the random variable of x denotes the number of yellow marbles, find the probability distribution of x. right? Now this is the bag which contains 3 white and 2 yellow marbles. Now when I say random variable, what do I mean by random variable? It tells you that all the alternatives that you can have. Now if I start drawing yellow marbles from this bag, what are the alternatives that I can have? The alternatives that I can have is I can have either 0 yellow marble, 1 yellow marble or 2 yellow marble, right? Now let's see this. The random variable x will be 0, 1 or 2. So when they tell you to find out random variable for a particular experiment, what does that mean? It means that you have to find out all the possible alternatives that you can have for that particular experiment. So here they have said that x denotes the number of yellow marbles. So what is the minimum and maximum number of yellow marbles you can get from this bag? You can have 0, 1 and 2 because maximum there are 2 yellow marbles. Now 2 marbles have to be drawn from the bag. What will be probability of x is equal to 0? Probability of x is equal to 0 means no yellow marble is drawn. That means all white marbles have to be drawn. There are 3 white marbles out of which 2 have to be drawn. Since I have to draw more than one object, therefore I am going to use permutation or combination, right? There are 3 white marbles out of which 2 have to be drawn. Total there are 5 marbles in the bag out of which 2 have to be drawn. There are 3 white marbles out of which 2 have to be drawn. Total there are 5 marbles out of which 2 have to be drawn. This is going to be nothing but 3 into 2 upon 2 into 1. How did I solve this? From 3 write these many terms in descending order. From 3 write 2 terms in descending order. So 3 into 2 and in the denominator from here to 1. So 2 into 1. Similarly this will be 5 into 4 upon 2 into 1. 2 into 1, 2 into 1 gone, 1s are, 2s are. So this is 3 upon 10. So probability that I get 0 yellow marbles is 3 upon 10. Then probability of 1 yellow marble. 1 yellow marble means out of the 2 yellow marbles, 1 has to be drawn. Yeah. Which? Previous. I want 0 yellow marbles. 0 yellow marbles means all the marbles have to be white. Total how many white marbles are there? There are 3 white marbles out of which how many have to be drawn? 2. Total how many marbles are there in the bag? Out of which how many have to be drawn? 2. Probability is n of a upon n of s. So number of elements in drawing a yellow marble is 3 by 2. 3c2 and total number of marbles are 5c2. Right? How do you solve this? Permutation combination 11th standard. From 3 write these many terms in descending order. From 3 write 2 terms in descending order. Descending order. So 3 into 2 and in the denominator this is going to be 2 into 1 upon. From 5 write 2 terms in descending order. So 5 into 4 upon 2 into 1. So this is going to be 1s are, 2s are. This is 3 upon 10. That's probability of 0 yellow marble. Next, probability of 1 yellow marble. There are 2 yellow marbles out of which 1 I am going to draw. Right? That means the other marble that I am going to draw is not going to be yellow. The other marble is going to be white. Total there are 5 marbles out of which 2 have to be drawn. There are 2 yellow marbles out of which 1 I am going to draw. And out of the remaining I have to draw 1 marble because I have to draw 2 marbles. So out of the 3 white marbles I am going to draw 1. So 2 into 3 upon 5 into 4 upon 2 into 1. So this is going to be 2 1s are, 2 2s are. This is 3 upon 5. Finally probability of 2 yellow marbles. Right? There are 2 yellow marbles in the bag, both of them I have to draw, and total there are 5 marbles out of which 2 have to be drawn. Cn of n is 1. C5 of 2 will be 5 into 4 upon 2 into 1. So this is going to be nothing but 1 upon 10. So you just write your answer here. This is 3 upon 10, this is 3 upon 5, and this is 1 upon 10. That's my probability of random variable x. Right? Next, take down next one please. 8 families have 0, 2, 1, 1, 3, 0, 2, 1 children. X denotes the number of children in a family. X denotes the number of children in a family. X denotes the number of children in a family. Construct a probability distribution of X. Construct a probability distribution of X. Construct a probability distribution of X. X denotes the number of children in the family. Look at the data. What is the minimum number of children you can have? 0. What's the maximum number of children you can have? 3. So, what is the minimum value? 0, 1, 2 and 3. You have to start from the minimum value and go to maximum value. Probability of X. How many families have got 0 number of children? There are 2 families. This is one and this is the other one. There are 2 families out of 8 which have got 0 number of children. So 2 by 8 can be then written as 1 by 4. So next, how many families have got one child, 1, 2, 3? There are 3 families out of 8 that have got 1 child. How many families have got 2 children? There are 2 families, 2 out of 8, which can be written as 1 upon 4. And there is only 1 family which has got 3 children, 1 by 8. Fine, sum is over. Next, let's take on next sum please. A dice is cast or dice is thrown if the random variable X is defined as X is equal to 1 if the dice result is an even number. And is equal to 0 if the dice result is odd. Find the probability distribution of X. Find the probability distribution. Whether I say random variable or I say probability distribution, it means the same thing. Find the probability distribution of X. Now guys, when a dice is thrown, the possible outcomes are 1, 2, 3, 4, 5, 6. These are the possible outcomes that you get when a dice is thrown. Now they are saying that random variable X is equal to 1 if the dice shows an even number. Right? Random variable X is equal to 1 if the dice shows an even number. Now which are the even numbers here? 2, 4 and 6. Which are the even numbers here? 2, 4 and 6. So random variable X will be 1 if probability of 2, for probability of 4 and for probability of 6. Right? These are the 3 even numbers. What is the probability of 2? There is only 1, 2. Total there are 6 outcomes. What is the probability of 4? There is only 1, 4. There are 6 outcomes. What is the probability of 6? There is only 1, 6 and there are 6 outcomes. 3 by 6. 3 by 6, that's going to be 1 by 3. So that will be the probability of random variable X is equal to 1. Probability of random variable X is 0. They are saying X is 0 when the dice shows an odd number. Right? Now, Odd number means either I should get probability of 1, or I should get probability of 3, or I should get probability of 5. For probability of 1, 3 and 5, these are the odd numbers. The random variable x is 0, they have specified. Probability of 1, there is only a 1 in the whole sample space, and there are 6 elements in the sample space. There is 1, 3 in the sample space, and there are 6 elements in the sample space. There is 1, 5 in the sample space, and there are 6 elements in the sample space. 3 by 6, that's 1 by 3. Next, take down next one please. 3 by 6, 1 by 2. For the cases it should be 1 by 2. So if you want to see the table, you will have x is equal to 0 and 1, and probability of x will be 1 by 2 and 1 by 2. That's my random variable table. Next, take on next one please. An unbiased coin is tossed 3 times. X is the number of tails observed. Find the probability distribution of x. Find the probability distribution of x. Find the probability distribution of x. A coin is tossed thrice. So if S is the sample space, what are the possible outcomes? 3 heads. Keep the tail on one side and move it to the other side. HHT, HTH, THH. 3 tails. Keep the head on one side and move it to the other side. TTH, THT, HTT. These are the possible outcomes. Now, what does the random variable x denote? Random variable x denotes the number of tails. Right? Let's make the table for random variable. Random variable x denotes the number of tails. Now, what are the minimum and maximum number of tails that you can get from that sample space? 0, 1, 2 and 3. Probability of x. Out of those 8 elements in the sample space, how many of them have got 0 number of tails? There is only one element, HHH. That is the only element in the sample space that has got 0 number of tails. So there is only one element in the sample space that has got 0 number of tails out of the 8 elements which are there in the sample space. Now how many elements have got 1 tail? HHT, HTH and THH. There are 3 elements in the sample space which have got only 1 tail out of the 8 elements in the sample space. How many elements have got 2 tails in the sample space? TTH, THT, HTT. There are 3 elements in the sample space which have got 2 tails out of the 8 elements. And there is only one element, TTT, which has got all 3 tails. So 1 by 8. So that is going to be my random variable for the number of tails observed. Next, take on next one please. A dice is thrown twice. A dice is thrown twice. Getting an odd number is termed as success. Getting an odd number is termed as success. Find the probability distribution of 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 success. Now, they're saying that a dice is thrown twice, right? Let us assume that S is the sample space of one dice. Now if a dice is thrown, the possible outcomes are 1, 2, 3, 4, 5, 6. right? Now they're saying that getting an odd number is termed as success. Getting an odd number is termed as success. So probability of success, right? How many odd numbers do you have in this? There are 3 odd numbers. Total number of terms 6. So probability of success is 1 by 2. Probability of failure, that means getting an even number is a failure. How many even numbers are here? 3 even numbers. Total there are 6 terms. So failure is also 1 by 2. Now if I cast a dice twice, now what are the minimum and maximum success I can get? Minimum I can get 0 success. Since I'm going to throw the dice twice, I can get 0, 1 and 2 success. The minimum success I can get is 0, the maximum success I can get is 2. Minimum success 0 and maximum is 2 because I'm going to throw the dice only twice. Probability of X. Now probability of 0 success. 0 success means on the first dice I should get a failure and on the second dice I should get a failure. On the first dice I should get a failure and on the second dice also I should get a failure. Right? Now, first dice failure is 1 by 2, second dice failure 1 by 2, 1 by 4. Probability of 1 success. Probability of 1 success means the first dice shows a success and the second dice shows a failure, or the first dice shows a failure and the second dice shows a success. In both the cases, I'll get 1 success. If I want 1 success, that means the first dice should show a success and the second failure, or the first dice shows a failure and the second dice shows a success. So this is going to be nothing but 1 by 2 into 1 by 2 plus 1 by 2 into 1 by 2. 1 by 4 plus 1 by 4, 2 by 4, 1 by 2. Probability of 2 successes. Probability of 2 successes means the first die should show a success and the second die should show a success. First die should show a success and the second die should show a success. So that's 1 by 2 into 1 by 2, that's 1 by 4. So this is going to be 1 by 4, 1 by 2, 1 by 4. So that will be my random variable for the number of successes. Next, take our next sum please. Our dice is tossed twice. Our dice is tossed twice. If the number appearing on the top is less than 3, if the number appearing on the top is less than 3, it is success. If the number appearing on the top is less than 3, then it is success. Find the probability distribution of success. Find the probability distribution of success. Find the probability distribution of success. Let us assume that S is the sample space. Now what are the alternatives? 3, 4, 5, 6. Now what is success according to them? They are saying that if the number on the top is less than 3, what are the alternatives? That probability of success, right? Number on the top is less than 3. There are 2 elements in the sample space which are less than 3. Total there are 6 elements in the sample space. So probability of success is 1 by 3. Probability of failure. There are 4 elements which are 3 or more than 3. Right? So probability of failure is going to be nothing but 4 by 6, which is nothing but 2 by 3. Right? Now I'm going to toss the dice twice. If I toss the dice twice, what are the minimum and maximum number of successes I can get? Minimum I can get 0 number of success. Since I'm going to toss the dice twice, maximum I can get 2 successes. Probability of 0 success. Zero success means the first die should show me a failure and the second die should also show a failure. Zero success means both the dice show a failure. So probability of X, first die shows a failure, is going to be 2 by 3, second die shows a failure 2 by 3. That's going to be nothing but 4 by 9. Next, probability of one success. One success means first die shows a success and the second die shows a failure, or the first die shows a failure and the second die shows a success. Success is 1 by 3, failure is 2 by 3, failure is 2 by 3, success is 1 by 3, 2 by 9 plus 2 by 9, right? So this is going to be nothing but 4 by 9. Okay, next, probability of X is equal to 2. Two successes. That means the first die should show a success and the second die should also show a success. First die success 1 by 3, second die success 1 by 3, 1 by 9. So this is going to be nothing but 4 by 9, 4 by 9 and 1 by 9. That is going to be my random variable of X. Fine, do we get this thing here? Next, take down next sum please. Find the probability distribution. Find the probability distribution. Find the probability distribution of the number of sixes. Find the probability distribution of number of sixes when a dice is tossed thrice. When a dice is tossed thrice. Find the probability distribution of number of sixes when a dice is tossed thrice. Let us assume S is the sample space. Now when a dice is tossed, the various elements in my sample space are 1, 2, 3, 4, 5, 6. Right? Now, success is getting a 6. So what is the probability of success? I'm going to represent success by small p now. Probability of success is 1 by 6. There is only 1 6 in my sample space out of the 6 elements in the sample space. Probability of failure. Failure I'm going to represent as q. There are 5 non-6 elements in it out of the 6 elements. Right? Now, X denotes a random variable. I'm going to toss the dice thrice. So what are the minimum and maximum number of successes I can get? Minimum I will get 0 success. Since I'm going to toss the dice thrice, maximum I can get 3 successes. So 0, 1, 2, 3. Probability of X. What's the probability of getting 0 success? 0 success means in the first try I get a failure, in the second try I get a failure, and in the third try I get failure. If all the 3 dices, in all the 3 tries if I get a failure, that will be probability of 0 success. That's 5 by 6 into 5 by 6 into 5 by 6. Right? That is going to be nothing but 125 upon 216. Probability of one success. Now this should be nice. One success means the first die shows a success, second shows a failure, third shows a failure. Or one success I want, right? First shows a failure, second shows a success, and the third shows a failure. Or one success I want. First shows a failure, second shows a failure, and the third shows a success. In all the cases I will get one success, right? P is 1 by 6, Q is 5 by 6 into 5 by 6 plus 5 by 6 into 1 by 6 into 5 by 6 plus 5 by 6 into 5 by 6 into 1 by 6. So this is 25 by 216, 25, 50, 75. So this is going to be nothing but 75 by 216. That's probability of one success. Then same way I can get probability of two successes. Two successes means out of the 3 tries, twice I should get success. First die shows a success, second die shows a success, third die shows a failure. Or first die shows a success, second die shows a failure, third die shows a success. Or first die shows a failure, second die shows a success, third die shows a success. In all the cases I will get 2 successes, right? Now let's see this. Success is 1 by 6. 1 by 6. Failure is 5 by 6. Success, failure, success, failure, success, success. 5 by 216, 5, 15, 15 by 216. Then probability of x is equal to 3. That means all the 3 dice show a success. First die shows a success, second shows a success, and the third shows a success. That's 1 by 6 into 1 by 6 into 1 by 6. That is 1 by 216. That's the probability of all the 3 dice showing a success. So my probability distribution table will be 125 upon 216. Next is 75 upon 216. Next is 15 upon 216. And the last is 1 upon 216. Next, data next sum please. Find the probability distribution of the number of times. Find the probability distribution of the number of times a total of 9 appears. A total of 9 appears in 2 throws of a dice. In 2 throws of a dice. Probability of success. Now when I throw a dice twice, 9. Let's first see success. In 2 throws of the dice, I can get 9 if I have the elements that would give me 9 would be 3, 6, 4, 5, 5, 4, 6, 3. These are the elements that would give me success. So probability of success is 4. When 2 dice are thrown, the total number of outcomes are 36. So probability of success is going to be 1 by 9. Probability of failure. If 4 times I am getting success, that means the balance 32 times I am going to get failure. Right? So which will work out to 8 by 9. Now, there are 36 outcomes when the dice is thrown twice. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, and that way I will get 36 outcomes. Okay. Now, how many times am I throwing the dice? I am throwing the dice twice. So what's the minimum and maximum number of success that I can get? Minimum is 0. Since I am throwing the dice twice, the maximum will be 2. Probability of x. Let's see this. Probability of 0 success. Probability of 0 success means when I throw the dice twice, I get a failure and a failure. First time I get a failure and second time also I get a failure. That's 8 by 9 into 8 by 9. 64 by 81. Probability of one success. I get first time I get success and failure, or failure and success. Right? Success. Success is 1 by 9. Failure is 8 by 9. Failure is 8 by 9. Success is 1 by 9. That's 8 by 81 plus 8 by 81. 16 by 81. Probability of two successes. I get success first time and I get success second time. Success is 1 by 9 into 1 by 9. That's 1 by 81. So my random variable table will be probability of zero success. Probability of zero success is 64 by 81. Probability of one success is 16 by 81. Probability of two success is 1 by 81. Right? Next, take on next one please. Two cards are successively drawn. Two cards are successively drawn without replacement. Find the probability distribution of the number of kings. Find the probability distribution of number of kings. Success P. Failure Q. I want success. When I draw a card, how many kings are there in a pack? There are 4 kings in a pack. There are total 52 cards in a pack. Right? So the probability of getting a king is 1 by 13. Right? If there are 4 kings, that means the remaining cards are non-king cards. So there are 48 by 52. That's going to be nothing but 12 by 13. Now I'm drawing 2 cards. If I'm drawing 2 cards, what's the minimum and maximum number of successes I can get? Minimum I'll get 0 successes. Since I'm drawing 2 cards, maximum I can get is 2 successes. Now let's see this. Probability of 0 success. 0 success means I get a failure first time and a failure second time. That's 12 by 13 into 12 by 13. That's 144 by 169. Right? Next, probability of x is equal to 1. I get 1 success. 1 success means success and failure, or failure and success. First card shows me success, second shows me failure, or first shows me failure and second shows me success. So this is going to be 1 by 13 into 12 by 13, and this is 12 by 13 into 1 by 13. 12 by 169 plus 12 by 169, 24 by 169. Probability of 2 successes. Probability of 2 successes. That means first die shows a success and the second die shows a success. First die shows a success is 1 by 13. Second die shows a success is also 1 by 13. So that's 1 by 169. Right? So probability distribution of x, 0 successes, is 144 by 169. 1 success is 24 by 169. 2 successes, 1 by 169. Next, take on another sum, guys. Two cards are drawn. Without replacement. 2 cards are drawn without replacement. Find the probability distribution of the number of queens. Find the probability distribution of number of queens. Find the probability distribution of the number of queens. Now let us assume that S is the sample space. So number of elements is S. Now instead of single card, I am drawing two cards. When you are drawing more than one object, you have to use permutation or combination. Since the order of arrangement is not important, you will be using combination. Right? Total there are 52 cards in a pack and I am drawing two cards. Total there are 52 cards in the pack and I am drawing two cards. This is 52 into 51 upon 2 into 1. That's going to be my number of elements in the sample space. Okay, now if I'm going to draw two cards, what's the minimum and maximum number of queens that I can get? I can get 0 number of queens. That's the minimum number. If I'm drawing two cards, maximum I can get 2 queens. So 0, 1 and 2. My random variable will have values 0, 1 and 2. Let's find out the probability. Probability of x is equal to 0. That means I get 0 queens. Right? Now, if I'm getting 0 queens, that means I'm going to select a card from non-queen. There are 48 non-queen cards in a pack, out of which 2 have to be selected. And there are 52 cards in a pack, out of which 2 have been selected. Right? So this is going to be nothing but from 48 I have to write two terms in descending order, 48 into 47 upon 2 into 1 upon 52 into 51 upon 2 into 1. Right? Now when you simplify this, you will get this answer as 188 upon 221. That's probability of 0 queens. Probability of 1 queen. Right? There are 4 queens in a pack, out of which 1 has to be selected, and from the non-queen cards 1 has to be selected, and out of the 52 cards 2 cards have been selected. C4 of 1 is 4. From 48 1 has to be selected, that's 48. This is 52 into 51 upon 2 into 1. Right, when I solve this, I'll get this answer as 32 upon 221. Next, probability of x is equal to 2. I want 2 queens. Total there are 4 queens in a pack, out of which 2 have to be selected. 52 cards in a pack, out of which 2 have to be selected. 4 into 3 upon 2 into 1 upon 52 into 51 upon 2 into 1. When you solve this, you will get this answer as 1 upon 221. Right? So that's my probability of getting minimum and maximum number of queens. Therefore, my random variable will be 188 upon 221. Next 32 upon 221. And last is 1 upon 221. Right? We'll stop this here for the day. Thank you very much.